This is now the third and final chi-square test, the test for association and independence. Let's look at an example. In a study of heart disease in male federal employees, very specific, researchers classified 356 volunteer subjects by two variables, socioeconomic status and smoking habits, essentially to see if there's an association between those two. The results are shown below. Is there association between socioeconomic status and smoking, or are they independent of each other? So, start looking at the observed counts. These, of course, are our observed counts. Let's do a little comparison with the previous examples of chi-squared tests. This, of course, is still categorical data, kind of like the homogeneity of populations. It's a 3-by-3 table. Right. Now, we're dealing with one population, though, where homogeneity of populations we were dealing with 3 in the last example. All right. In this case, we're dealing with just male federal employees, one population, but we are dealing with two variables, socioeconomic level, which, or socioeconomic status, which is broken into 3 levels, high, middle, and low, and smoking habits, which is also broken up into 3 levels, current, former, and never. In the goodness of fit test, the first video, we were comparing one population against theoretical values. In the homogeneity populations, we were comparing different populations against each other. Right? So we're kind of summarizing kind of the different tests. In this test, in the test for association or independence, we are going to compare the observed counts against what they would be if we assumed that the variables are independent. Right? You can already see kind of where the null hypothesis is going to come in. We're going to assume that they're independent. Well, what does it mean to assume that they're independent? What it means is that we can use the multiplication rule of probability, and that is how we are going to get our expected counts. Now, when we start to calculate expected counts, we're going to use probability. So you can see I'm starting to get probabilities here. In this group of 356 male federal employees, what's the probability of randomly selecting someone who is in the high socioeconomic status? Well, that would be 211 over 356. And we could figure out that that probability is 59%. Well, what's the probability of randomly selecting someone who's in the middle socioeconomic status or the low socioeconomic status, right? We can get those probabilities based on our first variable of socioeconomic status. Now we can shift and say, well, what's the probability of randomly selecting someone from the entire group that is a current, former, or never smoker? Well, we can get those probabilities. Now that we have those probabilities, and of course they should approximately add up to 1 with some round-off error, we can start going towards getting our expected counts. Because what we'll use are these probabilities that we just got and figure out each individual element in our table. The question comes down to now, what's the probability of randomly selecting a person that is a who has high socioeconomic status and a current smoker? All right, that's this position in the table. You can see with the and, we're talking about multiplication, all right? Because, and that only works if they're independent. All right? If they're not independent, you can't use multiplication rule. So there's where that assumption comes in. You can get the 59% of high economic status and the 33% of being a current smoker, and it turns out to be 19% chance, which is going to go in that position right there. Now, what we'll do next is, instead of talking about high socioeconomic status and current smoker, high socioeconomic status and former smoker, which is going to be that kind of position. We'll get the numbers and we'll place it in that position. And of course, we'll do the same thing with never smoking. And then we'll switch to the middle socioeconomic status and get all those. And then we'll switch to low socioeconomic status, current smoker, former smoker, never smoker. And we have all of these probabilities. Now, these are probabilities. And if we add them all up, they should. If we added up all of these, we should get actually 59%. If we added up all of those, we get 15%. If we added up all of those, 26. And of course, it works the same way in the other direction. If we add them all together, it should be 100%. These are not counts. They are probabilities. How do we get counts from probabilities? Well, we multiply by 356, our total group size. If we do that, we're no longer talking about probabilities. We're talking about counts, and there they are. Now that we have our counts, we can start the process. And of course, our counts should add up to 356. Now let's start the process. Step 1, right, is there an association between socioeconomic status and smoking habits? We're going to use the chi-squared test for association independence. Right? Verify the chi-squared test. Simple random sample? No, it's not, actually. These are volunteers. So there is the possibility for bias. We can continue, but only with the understanding that the results can't be generalized. Because these are volunteers, they might have something in common with each other. There might be a lurking or confounding variable, which is going to skew our data. So we just have to say the results are going to apply to these 356 people, and just be good with that. And of course, the counts are all above 1 and above 5. So we're going to continue with that caveat of not being able to generalize. Our hypotheses, right? Our null hypothesis is that they're independent. Our alternate hypothesis is that there is an association between the two. All right, so now let's calculate our p-value. Now, chi-squared, all right? Observed count minus expected count squared divided by expected count. What I've done is I've grabbed this value, and I'm finding the chi-squared component from that, then moving on down to former, and then to never. And then what I'll do is I'll move on to the middle socioeconomic status, do the same thing with all those values, get those chi-squared components, move on to the low socioeconomic status, and get all those. And if we add them all up, we get 18.51, which is our chi-squared statistic. The next thing, of course, is getting our degree of freedom, which will be done just like homogeneity of populations. So we have a degree of freedom of 4. From this, we can use our chi-squared CDF function, and we can get our probability, which is quite low. From here, we can start our interpretation of significance, our step 4. We have, with a 0.098 chance of drawing the sample, there is overwhelming evidence at the 0.1% significance level, very, very low significance level, for rejecting the null hypothesis in favor of the alternate hypothesis. There is an association, is our conclusion. But just like before, we can't stop there. We need magnitude and direction. For that, we're going to be looking at, again, these observed counts. And we're going to do this in a way which, again, is different than before, showing you a variety of ways of doing it. What we want to do now is do some conditional distributions. I'm going to make a little bit of space. Let's move step 3 up. All right, and what we need to do is start calculating for our conditional distributions, right, which is going to be converting these into percentages. So I'm starting off with my observed counts, right? What we want to do is make percentages. So we're going to divide, and we're going to go make the conditional distributions by socioeconomic status. So we're going down, and we're going to go middle and low, and that gets us all of our percentages. From that, we can draw some conditional distributions, which look like that. We have high socioeconomic status, middle, and low. Each one current, former, and never smoker. Now, I'm going to move that up so I can get a little space. Let's talk about current smokers. And notice that up here, I got the components for current, former, and never smokers of our chi-squared, because as before, talk about components of chi-squared and our observed data, which in this case we're looking at in terms of conditional distributions. So over 60% of the chi-squared value comes from current smokers. This 11.46 is 60% of 18.51. Indicating the strongest association is for current smoking and socioeconomic status. Which means if you know the socioeconomic status, you can predict, relatively speaking, whether they are a current smoker or not. All right, this can be clearly seen in the conditional distributions. As the socioeconomic status goes down, the percent of current smokers goes up. Right, here's socioeconomic high, middle, low, going down. Current smoker is 24, 42, 46. All right, they're going up as the socioeconomic status goes down. You can also see that in this row right here. Same numbers. So, and magnitude, low socioeconomic status is almost twice that of high socioeconomic status. 46 is almost twice of 24, just a little bit less than twice. So I have direction. As this goes down, this goes up. And I have magnitude. This is about twice of that. So magnitude and direction. Current smokers. Let's move on to former smokers. If we look at former smokers, as the socioeconomic rises, so I'm kind of starting here and looking at it this way, the percent of the group who have quit smoking, which is what former smoker means, goes up from 30% up to 44%. So as socioeconomic status goes up, rate of quitting goes up, which again can also be seen in these numbers here. That goes up from 30% to 44%, magnitude and direction. Now let's look at never smokers. And if we look at these numbers, then goes down, back up. There doesn't seem to be a clear association for the percent who have never smoked. So there's our full interpretation of significance with the detail of what's contributing to that association the most.